Well, hi, good morning. Thank you for joining me in my shop here. Today is October 5th. Looks like a nice day here, but cool. It's very, very cool now. So, I'm in the process of changing the capacitors in this radio. I've done 3, I think it was yesterday. And I think there's 3 more left to do. Let's take a look here. Let's see. What do we got? 1, 2, 3. Oh, no, I put that one in. 2. And what, just 2? Well, I thought there was 3. Well, okay. And what are the 2? So, this one is connected to the tone switch. And I'm pretty sure what's happening is when you switch it like this, you're applying a ground to this end of the capacitor. So otherwise the capacitor is ungrounded. And from the looks of it, I have to guess it's what's it connected to? I'm not sure what it's connected to. I think it's connected to the terminal down here. This other one is coming back to this switch. The switch very obviously is switching you onto the phono input. So we've got audio coming from the volume control, from the center wiper, to one tab on the switch, and then out through this capacitor on to the next tube. So all the audio is passing through this capacitor. Very good. No big deal. I think I'm going to change both of those. And then we're going to test the radio and start judging its alignment and just the quality of its operation. Okay, we're going to test these 2 capacitors. The first one is the tone capacitor. It's a 0.01. Same as the other one. They're both 0.01 microfarad capacitors. Okay, what do you say? 50 volts. What happens? So it opens up a little bit. That's enough right there to judge it. No surprise there. This one is the one that was carrying the audio signal. Okay, there we go. 50 again. Opens right up. 150. Not going to do it at 150, so it's not quite as bad as the last one, but oops, I'm sure it's worth. Whoa. That's what happens when you step on the camera wire. Okay. I'll put in a couple of new capacitors. We'll give the radio another test. Okay. Next. So here's the new capacitor there and a new one. You can't see it, or can you? Hidden in behind there. Good show. So we're hooked up to an outdoor antenna here, a very, very good antenna. So radio's off right now. Let's just switch it on and then apply power through the dim bulbs. The interesting thing about this radio, and many radios like it, if you notice, it doesn't hum. But I haven't done anything about the filter capacitor at all. It has the original filter capacitor in it. What I found is the radios that have a field coil speaker, like this one here is a field coil in here, which forms part of the filter system, it does not depend upon the capacitors nearly as much as a cheaper power supply without the field coil or choke coil in the power supply. Then you have these large capacitors, and the power supply is dependent upon those capacitors. As they wear out and get weaker, the hum starts appearing. It's very, very common in old radios. But if you have a field coil, seems to me, even with weak capacitors, you still get hum-free. Wait a minute, this is sound-free. What's going on here? 87 volts. Let's give it full juice here. Hey, what happened? Jim, what'd you do? Uh-oh. Let's flip the band. Switch. Okay. Didn't do anything. Again, these stations should be separate. They should be able to tune between them. Well, there is a little bit in between, isn't there? Not much though. So that's 860 and 820 running almost into each other.
Am I right? It can.
Yeah, you're right.
That's why we've encouraged as part of our recommendation to consider Faraday pouches, which is a radio frequency blocker that you can keys into, so that if you are at home, it actually
speaker distortion.
If you keep it in your bag, you can also keep it blocked that way, because people are getting access to it. And the challenge that we've seen is that when we look at what
somebody's rattling here.
Is that technology has exceeded where the vehicle standards are. So the last time vehicle standards were updated in Canada for safety was 2007. So
this outer piece here is loose. It's stuck right on the cardboard here. It's all come loose. That's where the buzz sound is coming from.
And preventing people from getting access to the cars.
Right. So, are these expensive, these Faraday boxes or pouches?
They're about $20, if not less. So, I mean, really, they're an inexpensive deterrent. Again, is it absolutely?
So you gotta do something about that.
But does it provide an extra level of precaution? Absolutely.
Is there any other technology that we can turn to help us?
I guess just throwing some glue in behind here, shoving this in. So, okay, we're going to ignore that for now.
Think about it from how we use our phones, almost two-step authentication. That you get your car started, you showers 15, but really cool Monday night down to a low of 5. Right now, it's 14 in Pearson. Our guaranteed high is 19.
14 in Toronto.
1024. Hey, it's Natasha Ramsahide, Chief Meteorologist.
For your car job.
Oh.
If you are considering...
I thought she was going to do the weather.
To buy another for me,
well, it's working fine on broadcast here. Except I have the feeling it's not at all lining up with the dial. We don't know, of course.
Or the play-in, let's say. Right at the play-in tournament? They probably
well, we should probably check that. Should probably throw it in the cabinet and take a look. Now let's just flip to the shortwave band. So the sun is going to put out a blast today, if it hasn't already, that could cause, it could be sufficient X-ray radiation to cause an X-ray blackout on shortwave, which would mean there's nothing here. Well, that's full volume. What happened here? Ooh, there's a station there. Well, I think I'm going to guess it's an alignment issue. If it were aligned better, it would work better. Let's put it in the cabinet and check the accuracy of the dial. I'll leave it here. This is probably 9.33. Let me get the cabinet. It's the cabinet without the most of the asbestos. There's still a piece in here. Jeepers creepers. I got it on my fingers. Okay. I'm just going to go and rinse my fingers briefly here. Okay. We're going to try to put this in with it operating. We don't normally do stuff like that. I don't think I'm going to do it this time. We're going to turn it off. Just not comfortable. This is interfering here a little bit. Right beside the hot tube there. Why are you resisting so much? Oh, I see why. Okay. Don't fight me, man. Okay, it's in. Good. So we're at 933, and look, this is up around 11. So I'm just totally wrong. It's probably is supposed to be there. We'll have to use a signal generator to really figure out. Here we go. We turn the power on. You see how the knobs are not quite lined up in the radio, and all this stuff is shifted over. Here we are. Sounds quite different when it's back in the cabinet, eh? So we're going to go down around the 9.3 and see. Huh, gotta wonder. Okay, and now we're going to go check the broadcast band here. We'll try the French station. 860 would be right here.
Great efforts being moved. Sphere Freight and Customs Brokerage. And at the bill, where we've seen the provincial government.
It's way out. There's the French station up here. And it should be way over here. So it looks like in both cases they're shifted way over. Why would that be? Is the pointer in the wrong spot? So the pointer's ending here. I think the pointer's in the wrong spot. And over here it goes off scale, way off scale. The pointer's in the wrong spot.
Have to go.
So there's various ways in which the radios hint at where the pointer should be. So usually you turn it to one extreme or the other. And often there's a little mark that you would never notice. Like see this mark out here? What's it doing way out here? There's another one kind of out here. But this one's very suspicious. It's way out there. If we head down there, it's way beyond the scale too. So this goes way past. Now, can I reach in there and slide it? I really didn't examine it, so I really can't do that. So we're going to take it out and hope that there's some mark or something to line it up right on the radio itself, because it looks like the pointer is the first thing that is way out on this radio. Okay, I'm going to stop for a minute or two, have a little coffee. So first thing I'm going to do is I'm just going to move the pointer kind of randomly closer to where it should be, as far as I can imagine. Now you might think if you're going to slide this pointer this way that you better hold the string here to hold the string in place. But in fact, if you do that, this thing will grab the string more and more. You'll never be able to slide it. The strange thing is you hold the string on the side where you're going to move it. And I'm going to clamp it like this. And then you try to push this guy. Okay, so as a guess, let me turn this all the way here. It's still coming pretty close here. I think too close, so I'm going to move it a little more. Just guessing. Better to have it closer than farther away. Let's send it down to the other end here. See how we're doing. Oh, that's got to be too far that way, because the capacitor's just closing and it's meeting up. So I've gone too far. So I'm going to move it back. I'm going to wear the string out is what I'm going to do there. Okay, so the capacitor is closed. And come back this way. There's really no reason to try to be precise. That looks a lot better than it was. What I'm going to do is I'm going to stick the radio back in the cabinet. I'm going to tune the radio according to the... You gotta think about this. I'm getting ready to adjust the oscillator in the radio. Probably the best thing to do is read the instructions. Yeah. How about I take a few minutes, read the instructions first. It's going to be straightforward, but nevertheless. And go have some coffee. Yeah. Okay, got a plan straight in my head here, I think. Anyway, I'm going to set the radio dial to 9. Oh, let's just check and see if I got the pointer anywhere near. Pretty close to this last mark. Let's go this way. You know, you see, it should come to this mark. So I haven't got it quite in the right spot. I probably can't move it while it's back in here. Can I do this with it off set? I shouldn't. I should move it. You know what? I might be able to move it because the string is fixed now. Let me just see if I can just push it a little bit. There we are. Okay, so that's lined up about as good as you can get. There. Go to the other end. I gotta put a knob on this, or I'm gonna. That's a little better. And it stops right on this mark. So those are the edge marks there. Excellent. Okay, so now we're gonna set this in the middle. I'm gonna pick. Why don't we pick 10? 10 is 1,000,000. Set this on 1,000,000. Okay, so it's all about 1,000,000. And if we look down below, oh, Jimmy, you're getting the wrong scales here. Come on, man. Well, let's leave it like this: 900 AM and 1,000,000. 10 megahertz actually. 10 megahertz, and yeah, I know what I'm doing. 900. I'm gonna dial 900 on my signal generator here before I forget. Hey, how come it's showing 0 frequency up there? This should have some numbers on it. What's going on? So we want to set it to 900. Something happened to my signal generator? Where are you, man? Well, okay, I'm kind of stuck here for a minute. Oh, you know what it is? This is set so low. Yeah, I know how'd that get. Oh, I know why it was set low. Okay, never mind. Everything's okay, and I'll be okay too. So we're gonna set this to 900. Troubleshooting everything. 900. Right. Just a touch lower. Okay, so we're sending a 900 signal over. You know what? I don't even have to do that. I did not have to do that. Okay, so 910 megahertz. You know what? Didn't I say something about I should read the instructions before I do this? Yeah, I'm sure I said that. Okay, here we go. Wasn't that terrible? Oh yeah, it's just terrible. Get the impression I'm rushing here. Rushing is part of the formula for an accident. Don't rush. No rushing. What am I hurrying for anyway? Okay, don't touch the tuning. Let's find out where this radio really is tuned. Using the signal generator. I'll switch the antenna connection here to the signal generator. There we go. And it's good. Everything's good. Power on. And we'll find out what the radio is really tuned to. If it's 900, I'll flip out. And do we have it on broadcast? Yes. Yes, it's on broadcast. There's that sound. Oh, it's on. Okay, and we're running with 110 volts. So tune the, I'm surprised how quiet this is. I'll tune the signal generator and we'll find out now what frequency the radio is really tuned to. Don't have this up too high. Okay, here we go. It's really tuned to 836. Now we're going to want to make it tune 900 here. So now I got to read the instructions. Okay, I'm going to have to, if you look at the tuning capacitor back here, you see both sections are the same size. One is not smaller than the other. In a lot of radios, one is smaller than the other. And that's usually the little oscillator. But we can't tell here just by looking at it which is which. But I might be able to tell by just interfering with it a little bit. You know, and another thing to look at, let's look again at the plates there. Do you see the outside plates appear to be bent away a little bit? Especially on the left set. Just a little bit bent out. That's probably been done very carefully in the factory as an adjustment. And this controls the linearity or the, yeah, I guess that's the right word for it, the linearity of the movement of the pointer against the scale at the back. But I shouldn't be touching those. So there's two capacitors on top of the big tuning capacitor. Whoops, sorry about that. I just slapped you in the face. You may not realize it. So I'm going to turn these a little bit. Oh, you know what? I don't have to. It's very easy. This is the antenna coming over, so it's obvious which one's the antenna. The other one will be the local oscillator. Okay. Metal screwdriver not having an effect. Now what I want to do is I want to change this and adjust the frequency here until it says 900. Let's go towards 900. Okay. Now I'm going to figure out which way to turn the screw here. This way. Oh boy. So that's right wide open. We only got to 850. Well, that's a bit of a problem. So with an arrangement like this, with the capacitor sections being the same size, there's often another adjusting capacitor that this one would be in parallel with the plates, and there's another capacitor in series with the plates. Maybe it's underneath the chassis. Now I really do have to read the instructions. I can't go any farther without them. Okay, instruction time. Okay, here we are. Let's take a look at what it says here. Let me zoom in a little bit. There. So this is what I was adjusting. And it says oscillator adjustment 20,000 kilocycles. Whoops. So I was fooling around with this at 900 on the wrong band. So this is really saying adjust this on shortwave. So I was doing this quite wrong. Come over here, adjust at 1500. So oh yeah, there they are. I didn't even see the little screw heads that are you have to put a screwdriver through a hole in the chassis to reach these. So this one is a 1500 and this one's 6. So these are the two that adjust the broadcast band. And you see there's two of them. In many radios there's only one, and the capacitor would be smaller here. But in this case you've got one in parallel, one in series. Let's see what it says here. Cathode ray alignment is preferable method. Connections for the oscillograph are shown in the RCA Victor service manual. Isn't this the service manual? Output meter alignment. This method's used. Connect the meter across a voice coil. Turn the receiver volume to maximum. Yeah, they all say that. But you know what? You got a radio turned up to maximum volume in your shop. You know what's going to happen. Test oscillator. Connect low side to chassis, keep output as low as possible to avoid AVC. And this is always the instruction that's given. And yeah, not that I'm smarter than all the other engineers that ever lived on the planet, but why exactly are you avoiding AVC action? Is it because it makes it difficult to spot the peak? I think that's the reason you're doing it. Because in fact, when the radio is operated, it's always operated with a signal strong enough to cause AVC action. So wouldn't you rather align it in a circumstance that's similar to what it would experience when it's being operated normally? But I won't argue with these guys. Besides, they're all dead. The alignment procedure is carried out in the usual manner. By no means attempt to align these receivers without the assistance of an accurate test oscillator and visual output indicator. By no means attempt it. Yeah, that's true. If you don't have these instruments, you do this blind, yikes. Dial indicator adjustment. Oh, here we are. Adjust dial pointer after chassis is securely fashioned in the cabinet. The pointer should be adjusted to the low frequency calibration mark with the gang completely meshed. And that's basically what I managed to do. So I got the pointer in the right spot anyway. Here's the instructions. So when we get around to this, doing the IF, I'm skip this for now and I'm fiddling around up here because I know the IF is working. And you know, that's a bit of a problem. If the you know what, I better not do this. I'm guessing the IF is close to 455, and that's I guess. If it's not, then I may have moved the pointer on the string for no good reason. No, that's not true. The pointer was definitely in the wrong place on the string. There's no question about that. How did it get there? Like, it had to be put there by somebody. Quiet point between 550 and 750, so I like it at the lower end. Adjust the two transformers. Now, I can do this, or I can just pump the signal in the antenna and hope enough of it gets through, which is the cheaper way of doing it. That's what I'm going to try first. First, we got to find out if it's on 455 or way off. Why do we have to use minimum capacity if two peaks can be obtained? So you got to be careful with this. Two peaks, the other peak would be the image, I'm pretty sure. If you're not careful, rock gang slightly and use a maximum capacity peak if two peaks can be obtained with C2. Check to determine that C4 has been adjusted to the correct peak by tuning to approximately 19.09, where a weaker signal should be received. So what they're suggesting you do here is you set the radio up at 28 megahertz, and then you go down basically double the IF frequency, and you should find an image there. And a really good radio, you wouldn't find the image because it'll be suppressed. But in these radios, they can't suppress the image at the high end of the shortwave band, and it's there to be heard. The problem is, if you tune down, if you do this and you tune down and you get a louder signal, then you've misaligned the radio. Or if the signal, you can't find it and you end up finding it 900 above, like that would be at 20.09, I guess. You find it there, you've done it wrong. They didn't quite include that. Oscillator tracks, oh, here we are. Here we are. They actually wrote in here, thank you. Oscillator tracks 455 above signal on all bands. Wait a minute here. Wait a minute. 20 megacycles. And then they're saying you look for the image peak below it. But then they're saying the oscillator is above. What? So this is breaking my brain here. This is backwards, isn't it? Isn't this backwards? By tuning. No, it's not backwards. Yeah. You know what? I'm all messed up. Once again, don't argue with the engineers, even though they're dead. Don't argue with them. I probably got it twisted around in my head. Voltages here, which I've never bothered checking. Okay. Great, well let's do the IF thing. Why not? Okay, so what I'm going to do is tune the signal generator to 455, feed that into the antenna. It's not really the right way to do this, or at least the way that they're instructing it in the alignment instructions. And we'll see what we hear coming out of the radio. Here we go. You hear it? It's very close. Let me turn it up a little louder. Tune again. I think this explains the broad tuning range in this radio. I think the IF is very wide. What we want to do is make this as loud as possible. I don't have a meter watching this. So without a meter, a metal screwdriver, not doing anything. I'm just checking to see if the metal screwdriver throws anything off, which it doesn't. So we'll start with the second IF, the one closest to the speaker, and I won't burn my hand on the tube here. At this point, just going to do it by ear. You could sort of argue what we're doing here is we're just getting the radio closer for alignment. The screwdriver's a little small here. Well, that's much better. If we had a meter, we get a little bit sharper yet. That's probably a lot better. So now we know that the local oscillator will operate at the proper frequency away from the target frequency. So 455, and this means if the IF is way off, the pointer the pointer will be off. The radio won't tune what the pointer says it's tuning, simply because the IF is way off. But it's not. Okay, good enough. We still have this right on 900. So now we'll take a look, and I'll be able to use the proper. We'll go to 15. We'll do this right. You know what? I gotta stop. I need a coffee break badly at this point. Yeah, coffee break. Right on. Okay, so what you're seeing on the screen now is the output of my SDR. SDR antenna is this coil here. So I've just shoved near one of the tubes, the mixer tube, in fact. The radio is on broadcast band right now, but the SDR is looking at the 10 megahertz band. That's where I believe the radio is tuned, or is attempted to be tuned, but it's still on broadcast. So I'm going to flip it over to shortwave, and we'll see what pops up on the screen there, which is being picked up by this coil. There we go. Okay, so a lot of stuff showed up. A lot of stuff showed up. So this one, I believe, is the local oscillator. And this one down here, this strong one down here, I don't know what this is. Let's just see. That's at 9.160, and this is at 9.820. So the radio is tuned to 900. The local oscillator should be at 900 455. So it should be, I'll put this red line over here. I'll put it right on 9455. So this thing here should be over here. And then the radio would be tuned to 900. But right now it's picking up, I don't know what's it picking up. I don't know, it's picking up something in here. So I'm going to adjust that same adjustment and see if we can't move Now, this is the instructions say do this at 20 megahertz. I'm doing it at 10. So we're going to try to get down there. So all kinds of weird stuff, but just watching the one in particular, which is just arriving at the red line. Now I've turned the capacitor into a very normal sort of tension, if you like. So I'm feeling a little better. Just trying to get it dead on. Screw's a little jumpy. Oops. There. Okay, so that's right on. So now this radio is definitely tuned to 10 megahertz here in the middle. And we know the local oscillator is above because I'm looking at it with an SDR. And of course, guys back in the 40s, they didn't have this kind of stuff at all. They had a crummy voltmeter. Good luck to them. But with this kind of technique, we can do things a lot better. So we know the local oscillator is adjusted properly on the high band, and I think that's all the adjustment for that. So now we're going to go down to the broadcast band. We'll change the SDR to the broadcast band here. Okay, so this is the broadcast band along here, and you can bet this is the local oscillator sitting here, and the radio is tuned to 900, so it should be 1355. So let's put the red line at 1355. 13, oh, way up here, 1355. Did I do that right? The radio is tuned to 900, and 455 on top of 900 is 1355. So we got to move this over to here. The instructions probably say do this at a very high frequency and a very low frequency, which is probably what we should follow. Hey, where'd this just come from? Did you see that just pop in there? What is that? What is that? That was some ham radio, I think. What's that? There's another one right beside it. It came and went. There he goes. That's amazing. At this time of day, how could this be? Okay. Sorry, I am a radio listener hobbyist, so... Oh, here he goes. I'm sure there's a ham radio band. Wow, I don't know if I've ever seen any activity down here at all. And it's 11 o'clock in the morning. Isn't this a middle of the night band? Look what's going on here. So there's weird things going on with the sun, but they usually reduce the strength of ham radio and shortwave radio in particular. Wow, isn't that something? Okay, never mind that. Let's get back to what I'm doing because I'm losing track. 900. So 13. Yeah, I had to set it, didn't I? 1355. 13. So we want to get the local oscillator over to here. And I just finished saying we got to do it at the high frequency. Oh, right. And then I looked over here and then I saw we're there. 1500. The radio has to be in the cabinet for me to do this. Or I have to go in and out, in and out, in and out of the cabinet. Shoot. I'm fascinated by this. Let's forget about the radio. Look at this. Where'd he go? No, this isn't ham radio. Ham radio guys don't talk like that. This is CB Skip. Well, what am I doing getting CB skipped down here? Oh yeah, you know what? It's the sun thing, right? The sun thing has caused some kind of atmospheric effect. And this, the fact that the radio is hearing it down here, there's something weird about the radio. But never mind that. Let's go up to 27 and see what's going on. It must be crazy. Some strange stuff happening here. 27. Here's the CB band here. Let's watch it. Well, I can click on some of these. Looking for the step setting. Well, okay, CB is rolling along, maybe not too surprising. Okay, not exciting as I thought, but I get a real kick out of listening to CB stuff. Looks like it's just down here on channel 6. Channel 6 is where there's something here too. Well, anyway, okay. Hey, how's that for a distraction? Excellent, excellent distraction, Jim. Now, back to what I'm doing. I had to make a decision here. So the reason I'm hesitant is there's two adjustments. There's one that you do at the low end and one you do at the high end. I've got the radio tuned in the middle. If you adjust these two with it in the middle, there's probably dozens of satisfactory combinations, but the ends here are doing weird things. So I don't think I can do this one in the middle. I really think I have to go up to the high end. I got to put it back in the cabinet and do all that stuff. You know what? I'm gonna stop at this point. I'm gonna stop now. Tomorrow I will do a proper alignment. We'll get more instruments on this and we'll align it properly. And because it's got a little late in the morning here for me. So and we'll finish it off tomorrow. Good, because I really do need to put more instruments on it. Well, anyway, we're set and ready to go. Radio's working. It's good. It's great. CB's happening. Sun is blasting. A big CME should be coming in this afternoon into North America. So if it hasn't hit already, keep your eyes peeled. Let's take a look. I can take a look here. This is the website that I like to use to make judgments about radio conditions and that. This is the NOAA website, and they have a number of dashboards, and one of them is called radio, and that's the one we're looking at here. So this is interesting things about the sun that has to do with radio reception. Right on the top here, it's telling you what it's seeing right in the last while, what it's seeing right now, and what it expects in the future. G3 is a big, that's a strong storm coming. And does it say when? Doesn't seem to say when. We see the radio flux is up at 291. Holy smokes. During the time where the sun is quiet in the 11-year cycle, this number hovers around 100 or even lower. No wonder. Wow. Okay, so this interesting display is related to X-rays coming from the sun and the effect the sun's radiation is having on the atmosphere. I'm gonna play this. Let's just take a moment. Downloads, and we'll just watch it. So the sun is up at this time of the morning. Earlier this morning, the sun was over top of Indian Ocean and coming over Africa. There's a little blast there. If this thing goes red, then we're looking at an X-ray blackout. And slowly the sun is moving, coming this way. So this would be, I don't know what time, 10 o'clock UTC in the morning. So this is early morning here. In fact, the sun hasn't even got to me yet here. Although you can't use this as as sunshine. No big blasts. So there was a huge one here yesterday, I think. Yeah, it occurred right in this area. And then that's probably the shot that the CMA, which is going to hit us, came from. A couple days ago, I guess. Yeah, nothing too exciting there. And these other things you can... So anyway, this is a very, very, very useful. There's other websites too that are also very useful, but this one's quite useful for. So we're waiting for this to come. You know what? There's another display here which is worth looking at. Let me find it. I'm gonna go look at the. Where's the power on? Electric power. Well, this is showing voltage gradients in the earth. But that's not what I'm after. Not what I'm after. What am I after? Dashboards, and how about this one? One of these. There we are. This is what I'm looking for. This guy right here. So we're going to play this. Now there's a lot of information on here. So to make it real simple, this little green spot here is the Earth. These two are satellites. This is the Earth. This is the Sun. And this is stuff coming out of the Sun. Now it looks like it's in a spiral because the Earth is moving. So, but in this image, everything is frozen. So instead of the Earth moving, you see all the stuff moving. So that's why it's in this weird spiral shape. They de-spiral it over here on this one. So you can just look at what is coming out of the Sun straight at us. So right now it shows it to be pretty quiet, but that's not right now. That's some time ago. And so this is dates, I think, across here. 3rd, 4th, 5th, 6th, 7th, 8th, and 9th. I'm not exactly sure of that. Let's play this thing. Showed my wife this last night. There, you see the blast? That's not the blast. Here comes the real blast. This is what we're waiting for, this red thing. Boom! That's today, tomorrow, something like that. So you can study this too, and unfortunately I have some trouble determining. Oh, so here's the time. The time is written up here. So okay, so this is hours here. No, it isn't. So down here, these are days, and this is the hours. So, and UTC. So 03 UTC, that's 22 minus 4. So this is in the evening here. What's today? Today's the 5th, right? This is the evening. Actually, you can just look between the 5th and the 6th and figure out where you are in the day. So I'm in the evening here. Kapawi, in the evening. Kapawi. So this evening, around 11 o'clock. Wait a minute. It's not this evening. That's just after lunch. That's right now. That's right now. Anyway, you can figure this out better than me, probably. So, but one thing for sure, something's going to happen today. Watch for X-rays. Not X-rays. Not X-rays today. No. Okay, I'm done. I'm finished. I'm done for the day here. Thanks a lot for watching, and a little bit of a crazy video at the end here, but hey, why not? See you on the next video.